the email that's used over in and access the repository. So I was told that so the image data, so the raw data is from like I think it's just like image from the Norway, and I'm pretty sure there are a lot of pre-processing work to label this image and a lot of and also some like manual labeling work about this image, but the image was used to detect the parking lot, but there's also the primary for the use of the like medium duty and heavy duty trucks. I'm not sure if you guys
they were only doing it for trucks.
No, I think it's like the parking lot with those medium duty and heavy duty, but those vehicles are primarily trucks, not like the light duty we are focusing on. And also for the I'm not sure. It's like is that evidence was used? It's also used to generate the parking capacity, like say the space of parking.
Are you trying to generate the number of parking spaces that are open and how many were occupied by?
You mean from that paper?
The paper? The paper was just trying to detect from what I read. It was just trying to detect the number of cars.
Number of cars. Okay. I see. Okay. Which is not. If that case. When I don't think they can use that training data for our use case.
No, I'm sorry. Yeah, I don't think we can either.
Yeah. Either way. So early today, and I tested one approach, which is.
Oh no! It's only no. It was only trying to detect truck parking lots.
That's right. Okay.
It won't work for us. Yeah.
Right?
Yeah, it won't work for us. Yeah.
Okay. Either way, I think that could be not applicable for us, but
yeah.
They do have the code and you can share, but it seems like they just checking, if you to interested can include clean up codes and but I would say for now you have to focus not on that scope yet.
Yeah.
Yeah. Anyway. So what I did this morning, which is to download a few sample, basically GIS data for one, for one area, and it has. Let me what I would rather to share this one with you. Okay. Okay, this is from the first define. So they have few data sites. And just test out those data sites, which is the parking lot. The parking lot, this sample, they have this vector polygons of the parking area. Mm-hmm. You see, this is one, it's like area, and so just like the trajectory of the vector polygons of the parking space, and also some the building sites around this area. And this is what exactly I want to do. So we just use it for EV charging and site selection studies, and also used by the EV infrastructure planners. This is what our original scope, right? Mm-hmm. So which means this is the primary input, which is parking lot polygons. The shape effects, right? So I test out and based on vehicle, this is just like the try. And from the, I think primary, which is the shape files, which is SHP. This is kind of like the vector polygons of that areas. and give me some output, just like the random site. I know I just, okay, just give me an example site. And this site has parking space. And this is like retail. This is very just a retail center, right? And this is building, and the highlight vector polygons are parking space. So basically, a few like major building complex, and the rest of the areas, the highlight here, I think primarily just parking space. And so this is kind of like alternative way to do it, which is like based on the parking areas, and you just specify one parking space. The area is like maybe, let's say, 50 square feet. Let me see, 4, 5, 20, 30 square feet. And so for the designers, they have the, like, if you have this kind of space, about like let's say roof, like it's kind of a roof zone, which is like, okay, 75% of this space would be parking space. And assume this each parking space like 50 square feet, and this is number of parking space I can estimate. It's a very simple way. I mean, it's not accurate, but I think from planning purpose, that should be enough to, as the like, okay, for this site, the first manager or anyone or planner, they want to use the tool. Just, okay, give me the location of this site. And I just like have this site of the parking areas, vectors, shapefile, and then, okay, just give you some like, okay, I think that I just put some examples here, and just give you like, okay, this is number of parking space, and just fill out like this is kind of like the first screening process, which is, okay, give me this number of parking space, and I think I feel like seeing definitions over here. One second. Yeah. Is there a fund? You can see these 3 type of scenarios.
Pilot.
A pilot 5%, care green 10%, aggressive 10%, which means like 5% of the parking space or 5% of the vehicles can be electrified with electric vehicles, as I just mentioned, or 10%.
Okay.
Give like care greens, like some goal of care greens, or either like aggressive goal. We're going to electrify 20% of those vehicles in this parking lot, right? And given those inputs, and we can just estimate, okay, how much vehicle to be electrified and how much load going to be added on the electricity demand, and how many charging stations we need for L2, L3. I don't think we have L2, L1. So this is a way, I think, as a basic input. Okay, just estimate the number of the parking space for the planning use.
So all you want us to build a model that just estimates the number of parking lot spaces?
Well, at the beginning, we think we just give you some like low resolution of satellite image.
Yeah.
Based on that image, you can just give me a estimated number of parking space.
Okay, just an estimate, that's it.
That's right. But things like, the only things like, first thing, we just want to make it work. Second, improve it. Because like the estimate can be like 6% accuracy or either 70% accuracy, right?
And so this is but you want us to use this data set, right?
I mean, this is just the way I want to so now the use of that D part doesn't work. So tell me what you can proceed to get that number of parking space so far.
Tell me what?
So over the last 2 weeks, you have already figured out the way to get the number of parking space, right?
Yeah. Yeah.
So what's that? So basically, but it seems that from that approach, you need a lot of like training data set to do it.
We used, yeah, okay.
Yes, it's correct.
Is that right?
Yeah.
Or if I take like one like screenshot of that from Google Maps or either the Google Maps API to take that image, give you that image, can you tell me the number of parking space?
No,
Right?
it won't. Yeah. Because are you asking if based on my trained model right now, will it be able to detect the number of?
Yep.
It won't be.
It won't be, right?
Because
so that's why. So to make it work, so basically this is one step of work, as it towards to the end.
Okay.
But if that like like it doesn't work, I would rather stay to this simple approach.
Okay.
Just give me a shape file, or either I would just put out this shape file in one like city, or let's say city of Berkeley. I have all these shape files.
Mm-hmm.
Right.
Like a picture of Berkeley, the Berkeley city.
So this kind of like thing, this is like just like this is just one example, like in California in one area.
Okay.
And so let's stay with this approach, since like I need to figure out a way how to generate this shape file. Otherwise, we need to go. So basically, this is one. This is one area in California. Something kind of like city level or whatever. It's like just like one zip code or either right. This zip code area. This is data, sample data, and pick one location. Okay, say this is a site, and this site come with this like parking areas vector polygons.
Mm-hmm.
So this is how, given these areas, and we can calculate the areas of this parking space. Give the this is, I think this is not very clear. Okay, give the like 40% will be occupied by the parking each parking spot, and we just estimate. Just based on some like designers rule of thumb, factors.
Okay.
So are we assuming the parking spots are the same size for each lot?
Yes.
Okay.
Otherwise, this is what I think this can work so for the simple input. Or if we, let's say, for example,
What is like a simple input in your?
Just location, the geolocation of the one site. Let's say this is building.
That's a simple input.
I'm not like say Whole Foods.
Okay.
Okay, this is the Whole Foods.
Okay.
And if you define a builder name, this is the builder name. Let me just hold on a second. Let me just pull it up. Okay.
Okay.
This is one site, which is like I don't know what this one. Just let's assume this is site.
Mm-hmm.
They put input. Okay, the type of building, retail, and or grocery store, and the location, which is geolocation. Just give me this like longitude and latitude.
Mm-hmm.
Right? This is geolocation. Or either you can just give me like the address, which is like 3502 Mountain Diablo, blah, blah, blah. This is the location where I can locate. And given this location, and given that shape file, I can estimate these parking areas that related to this building. This is parking lot for this building. And then based on this area, you will assume one parking space, which is like 20, 30 square feet.
Mm-hmm.
And then, 50% of these areas would be parking space. We just calculate this number of parking space.
Okay.
Okay, this is the approach. I think definitely going to work for the planning use. The accuracy may be not that high, but this is going to make it work. But since like at the beginning, I was thinking, if there's a low resolution satellite image, based on this image, can we do automatically calculate this parking space or either number of vehicles? or so basically like I think better you to already try the like put like a box like a
The bounding box,
yeah, it's kind of like a boundary box, right?
Yeah.
Do you think the boundary box, if you give this like image, can fit into this one to calculate the number of parking space?
Like the thing, like no, because
No, right?
yeah, no.
Okay. Why?
Because
Because
it was
we don't
trained on a
need-
different
yeah.
type of data set. Like the data set was a lot more clearer. It was very clear.
Yeah.
And so it was like it was really easy to see and because it was trained on that data set, on those type of pictures, it works really well. But then when I feed it onto if I were to feed it an image like this, it would work horribly. Because
Okay, I see.
it's a lot more zoomed in, it's a lot more clear on those pictures. But I think if we had a data set, something like this would be extremely difficult to do. But if we had a data set like this, I think I could be able to train it.
But we would need thousands of photos to do
Yeah,
that.
that's the only problem.
Which is very
Yeah, okay, that's the only problem we got. Yeah,
That's the very big problem though.
Okay.
Like we have
Okay,
a model
if
that
that case-
works, but yeah.
If that case, I think let's just take this simple way to do it.
So it basically estimates the number of parking spots and then says, hey, 40% of these parking spots are
Yeah,
going to be.
that's right.
And do you want us to create a model for this? Should it just be like another machine learning model for that?
No, I don't think so. It's just like it's gonna be rule based for now. This
Okay.
one. Okay, I think this one. Let's. I will just hand over to you
Okay.
and just integrate in our workflow. Okay,
Okay.
let's just take this one off the list. What about the driving activities?
Did you look at the work? Can you hear the Google chat really quickly between us?
Which one?
The Google
Google
chat.
We had a few questions. in
Yeah.
the chat.
If you just share the screen onto just share the screen of the Google chat.
Okay, let me see what you got. Hold on a second.
Yeah, could you go up a little bit? So yeah, could you
This one?
No, a little bit more. No, not this one.
Not this one. Okay.
This was our data analysis. Like just this message right here. Go up a little bit. Up. Yeah, right here. This one right here. So we just were a little confused. So this is currently our pipeline on what we're gonna do. So it's gonna like this parking lot thing. So first we take a picture of a parking lot.
Okay. I think this part we just discussed.
Yeah, that's the part we discussed, right?
Okay.
So then from there, we're gonna estimate the number of employees, and then we're gonna generate the synthetic the driver profiles of each data. Using so what we did was we took the NHTS data set, right? We then analyzed it for how many were going stopping between work and home and all of that different things, right?
Yep.
So based on all of that data, we're going to generate these synthetic employees and then use the data we took from that data set onto this.
That's right.
20%, if 20% were stopping before they went home, then 20% of our employees will stop before they go home. And so that's what they're doing, right? And then from there, we're going to estimate the charging demand.
Yeah, that's right.
Okay, that's right.
Yeah.
Okay, so so right now this is our pipeline. We did the data analysis. That was, if you go down, that was the picture I sent you.
Which one?
This picture right
black
here, yeah.
one.
And then Isabel, if you want, because then Isabella realized that we low-key didn't take into account how many were going to be EVs.
So the problem is that we don't have data, like the NHTS data doesn't specify which cars or or how many cars are electric vehicles or hybrid or gas powered cars. So what we were wondering was, would you like us to just make an estimate and say okay, based off this income, 30% is going to...
No, we don't care about what car they drive. Right now, we just only got their drive activities.
Oh, we don't care about the car they drive.
That's right. We don't care.
Okay, never
But
mind.
things I'm thinking okay. So this example data I share with you. This is just a code book. No, this is all the attributes, right? Did you guys open this one?
We did, but
but we were confused on how to read it.
This is kind of, if you go to if you download all the like kind of data set. This is kind of like all the survey
Oh,
data.
okay. I see.
So since like if you see some like the output of survey output, they're not going to give you exactly the long like text of that selection. They just give you the code. Okay, 31. But this is kind of like you need to match. This is kind of like original. So is this kind of like the code to?
Oh, so this is like
attribute?
the key?
Yeah, I think so.
The
Yeah.
legend, okay.
So you
Okay.
can see here, okay, total number of the household, you probably will see that the data would be 4, or I mean, this is just number of like, but things like if you see, okay, the result household Asian, it probably just give you 3, or maybe 3. I'm not sure, I forgot what the exact 5. But this is kind of like for each key represent the long text as a descriptions. Right?
Yeah.
Let me see.
So yeah, that's currently where we're at on the pipeline.
Okay.
But
Since at first, I probably want to do some like cluster analysis to see. And basically, I think this is going to be a very tricky task. It's things like you need to apply some like cluster analysis to cluster those drive behaviors that associated with like different demographic.
wait,
Right? I mean, let's say for this, for example, if it's couple, it's a family of 4, and they have little kids, and their household, whatever, if there is like, his household income is like 100K above, and they may have like 3 or 4 like driving activities of the day. Is that irrelevant? So basically, there's a lot of like cluster analysis and correlation analysis to group all these activities in each clusters. But okay, this is kind of like
how do we do
if
that?
I can do it, I think again, this first thing I can just start explore. And now, what do you guys have tried to analyze the data set?
Wait, what did you ask?
What do you guys have already tried to explore the data set?
We just
Generate the activities.
We just had Notebook LM
Yeah.
summarize the data for us.
Then what?
We had Notebook LM summarize the data and cluster it, and then we had code create
Okay.
relationships between, or Claude code to
There was-
create relationships between the data.
like there were some things that Notebook LLM couldn't find just off that. Like it couldn't find. I forgot what it was. I can't exactly.
Do you want to share something or just like still?
No, the screenshot that I sent you was everything we found out from Claude itself. But there was some things it didn't know like, okay, like from what time to what time was this person at work? What time
Yeah.
were they home? Those type of things wasn't in specifically the NHTS data set. So that's what we got through using Claude.
Okay. I
So-
think they have some like schedules. Very.
When we checked, they didn't. We checked more. I mean, wait. Hold on. I think there was. Oh yeah. One other question. What if like this beam? Okay, wait. Actually, do you?
Why are you talking about beams?
Wait. What exactly did you want us to do with the beam? It was just a reference, right? It was just.
It's just reference. Yeah,
Okay.
it's reference.
Okay.
Wait, why don't we care about the type of vehicle? It's
No, we don't care. We don't care about type of vehicle. We just care about their driving activities. We assume they all drive like light duty vehicles.
wait, we're assuming they're all EV.
Do they have that? No, we also just like internal combustion in just typical vehicles. I'm not sure. So is that in that survey? Do they have any like the type of vehicles?
No, they
No.
didn't.
They don't.
No,
right?
I was
Because, sorry, yeah.
well. I just like with. My concern is that it's going to create these profiles, and then they're all going to say that all these different profiles need EV charging, and then we have over demand, an overflow.
I didn't catch what you want to say.
Well, all these different driving profiles. Are we assuming that they're all driving EV vehicles, electric vehicles?
No, we are not assume. So here's case. So let's say. So we already get this part. Okay, number of
Yes.
vehicles, number okay, and as it in the code, we assume 5%. Those vehicles can be electrified, which means we assume those vehicles all gas vehicles.
Okay.
Okay. Since here you have like say 90%
Yeah.
of the fuel is which is gas vehicles, right?
Yeah.
And if it's, first, it's okay. Let's say if I have 100 parking space, we assume like 8 of these vehicles are electric or either hybrid. We just leave it alone. We ignore it. But since for the 92%, we think okay, 5% of these going to be electrified is one scenario, or 10% would be another scenario. But it seems like for 90%, just like let's say 100 vehicles, but how we can, so basically I want to ask you to do is that generate a database of driving profiles or either activities. So based on that database, I can sample all these driving behaviors assigned to each vehicle.
So basically what we're saying, just use this data to create the profile.
Database, that's right.
The data, okay, the from what, okay, yeah.
A database of driving profiles. No, I mean activity profiles.
Okay.
You know what I mean? Okay.
Yeah.
So, do I have this something? Let me see. I think did I share the Excel about the example like activities, CSV? I think so, right?
I'm pretty sure you did. Is it in the Google? It might be in the Google Doc.
Yeah, the Google Doc. Okay, let me see.
I don't know. EV charging. EV charging. Yeah, that one right there.
Oh, this one. No,
First one.
First one.
Yeah, I don't know. It might be in here.
But since I remember that's the one CSV. Oh, here we go. Let me see. Do I have it here? I don't think so. Template, no. No, not here. Let me see. I remember, did I send an email to you or what?
No, I don't. I remember we saw it, but I don't remember how we saw it.
You might have sent it on Zoom.
No, maybe we ran the V2G sim.
But I do send over. Let me see. Okay. No. Oh. Oh, I think in that Google Drive, in Google Drive, if that's correct. Let me see. Oh, this is one. Have you guys checked out this one? This is your project folder.
Wait, open it.
Yeah. So this.
Oh, I remember seeing this.
Remember this one, right? It's gonna be similar.
Okay.
Let's see. We have like 10,000 vehicles. I mean, you can not think about vehicle ID. You think about employee.
Yeah.
Oh, it's like like a driver ID. Okay. We have 10, you can just have 10,000 for each driver. You can have another like you can have a separate demographic information associated with driver ID. Okay, driver ID 1.
Okay.
Okay, probably just like just couple, a family of 2, and their demographics and for each day they have like only 2 uh, interests from home to office, office to home. That's it,
Okay.
right?
Yeah.
And okay, you know what? Think about this driver ID 1 and family. I don't know. I just pick it up. Okay. And number of vehicles, I don't know, maybe just like 2. And number of trips, whatever, like 3. Okay. And then associated with that number of trips, whatever, you can do it along cluster and correlation asset. Make sure to get those number 1, number 2. Oh, either like you can think about like driver clusters ID. Okay. This kind of home to home office and home to daycare, whatever, it's like, and store and store and home. So this is what I want to see. From all the database, from the National Transportation Survey, I want to get this kind of like driving activities that can be clustered for each type of clusters that are associated with demographic information.
From the data set,
Yes,
using the data set, the NHTS data set, you want something like this.
that's right. So this is the one I can just sample all this information to, okay, maybe I have 100 clusters. I would just randomly pick, and for each cluster of drivers associated with this driving.
So each cluster is a different type of social demographic.
That's right. Yeah, that's
So
what I'm
like
thinking about.
car ID 1 is like a single female. Car ID 2 is like a female with one partner, like that.
Something. Well, this is what I want you for, right? I for now I cannot just give you exactly what it's going to be.
Oh,
like.
it's just whatever we want.
That's right. But things like whatever you want, basically that can represent. Think about I have an office. I have 100 employees.
Yeah.
10%. It's like just 10% like just singles, or 10% couples, 30% family of 4, and another percent just random. So basically, think about those different clusters.
Okay.
And for each cluster, how the driving activity is going to be like.
Okay.
This is kind of synthetic data set I will learn from the National Transportation Survey data set.
Okay. Okay.
Right?
Yeah.
I think for this week, let's get that one done.
Just try for this. Okay. Then we can do that. We can
get a working. Just get a working version of it, and then.
Wait.
Do
you want? Okay, I'm confused. Do you want us to create a model that does this for us?
What do you want a model?
Because you're saying create a working model. Like you're saying create a working version of this.
What means this is kind of like the workflow you guys put together, right?
Yeah.
And since the first steps use the image, it doesn't work for now since the lack of training data set. This is how we want to use the shape factor. Okay, let's just cross it from our list.
Okay.
And this generic synthetic employees driving working schedules, commute distance, this assigned role, this thing,
Yeah.
we need to work it out.
Do you think we can do that? Okay, so based on the data that we got from the NHTS data set, we got a bunch of that data. What we can do now is just to generate those synthetic employee activity driver profiles. Can't we just use that data in order to do that?
Yes.
So over this week, I think that's what we can work on then. Because I think we already have the data. All we have to do is just create now, just using that, if we have something like, okay, we have 40 employees. So we create a driver activity employee of all those 40 employees from our office. That's kind of what we want. Okay,
that's right.
That makes sense. I think we can do that. I think that's what we were going to do anyway. So
Yeah.
Okay, does that make sense?
Yeah, that makes
I think
sense.
so, right?
yeah, that makes sense. That makes sense.
So this is but it seems like you two need to do some brainstorm to work. So basically, think approach. Right. Okay. What type of this is kind of like very generic workflow, but things like in terms of like how to generate synthetic models, just employees. What type of cluster approach I can leverage? What type of correlation analysis I can do based on data I have, right? So that's going to take a lot of effort to two of you.
Okay.
Develop approach and implement and generate the driving profiles as end for this week.
Okay.
Okay.
Sounds good?
Yeah.
Okay. And after that, the following week, which is like, how many weeks do we have? About like
Yeah, so this is there's 3 weeks
right?
left, including this.
After this week, we have 2.
Okay. So next week, we're going to integrate everything together to run end-to-end simulations and for one use case.
Okay.
And probably just like 3 days for the integration and a couple days from mid of next week to 20th or 21st, get the dashboard.
Okay.
I will give you only give you like a couple days to
I think we only need a day.
produce the final presentations.
It won't really create. We won't need a lot of time for that.
Okay.
Yeah, what we were planning is going on the tour that you recommended to us, and then like having that day to like finish everything with our presentations. So we would only need the 23rd for that.
23rd, you want do the dashboard?
No, can we
What day?
practice? We want everything done by that date, and then on the 23rd,
Yes.
practice.
Definitely, we need everything done by Thursday, since you guys going to have a final presentation on Friday, right? Okay.
And then practice presentation.
Yeah.
So that Wednesday and Tuesday before the Thursday would be focused on the dashboard.
Yep.
Okay.
If you use the web coding for dashboard, but just matter of like how you design and for the planning mode, it can take a couple days,
Yeah.
Okay.
But seems like for this week, let's have a check-in sometime on Thursday or either Wednesday.
Can we do Wednesday?
Yeah, we can do Wednesday. And let me just follow through what you have done.
Okay.
Okay. I think that's it. Okay. So for this side, you download from the Transparency Survey website. I think it's a big data set, right?
We didn't download everything. We only downloaded some of the files. Not
Yeah,
everything.
By
only
location, by
downloaded-
California, or just for the intent? I don't think.
Wait, for NHTS, we did the entire. It was the entire.
But only the 2022 data.
Yeah.
Only 2022.
Yeah.
But still, I think it's like it's like over a gigabyte or just like a few hundred.
It was. We didn't download every single week. We didn't download. Hold on, let me go there. Where is it? Wait. Profiles. FL.gov. We didn't download how there's different sections like drivers and things like that. Like drivers, we didn't download every single. We only downloaded 3 of them, so there wasn't too much to download.
Okay.
Because all the other analyzing data we could just get straight up through a notebook at LLM.
Okay, make sure you get full. I'm not sure how that data set. I forgot how that data set organized. Probably just one data set include everything that I show you in that the code the code book. The Excel. Most likely to cover everything. Yeah, I think that's pretty much of it. Again, our focus which is like kind of like workplace charging, which is office, the primary sector, and for the retail, let's just leave it behind.
Okay.
Yeah, think about in the home charging and workplace charging. Workplace charging is currently our focus, which is either office complex or either some like industrial park. There's a lot of industrial park in South Bay, right? I was thinking there should be some like use this, but primary use of the two going to be some EV charging planners, EV infrastructure planners. Yeah. Okay. Let's have check in on Wednesday and see how it go. And I think that's pretty much this week's the goal.
Sounds good.
Okay.
Yes.
And for the presentations, I think this can be a few slides about the data set. Analyze, it basically kind of like is exploring, of the data set.
Yeah, and then using
to create a cluster of the driving profiles. This can be hard. I mean, just you two can definitely. This is kind of like a major task for this project. Okay. It'd be fun.
Yeah. Bye.
All right, sure. Bye.
Thank you.
Sure. Bye.